Okay, so first, the 90 minus x is the opposite angle, so it would be this one. And then it was the cosine, so it would be adjacent over hypotenuse. And then we use the Pythagorean theorem to get this, which was 9. And then the tangent of x, which was this angle, would be 40 over 9. And then the sine of x would be 41 over 40. 40 over 41, and then do you want to do the x?
And then we can just, I did the sine of 40 over 41, which are the sine inverse, and that is 77.3.
So first you use the Pythagorean theorem to find segment EA, which is root 80 in the same thing. Given 12, and then you could use the law of cosines to find the angles in triangle EBC, or you could use
Okay, so then I found the length of this, which is 249, and then I used the sine to find the sine of E is equal to 8 over 12, and that gives you what this length is, which is 41.8. And then I use the sine again to find the whole angle, so it'd be equals 13 over 30. And then I found this, and I subtracted this, or I subtracted this whole thing by this to find what this angle was. Correction, instead of sine, it's tangent.
Hello, everybody. It's Clark Giansanti here with Evan and Sean Chambers. It's Chambers. It's Chambers. My bad on that. But what we have already done is draw out the triangle, which is recommended, but you don't need to. So first, we're going to try and find angle C because it's the biggest angle. And so for what we did with that, we set up the law of cosines, with 20 being by itself, and then everything else putting in 10 squared plus 11 squared and so on. And for that, we got the answer for angle C to be approximately 144 and 5/10. And since now we got the biggest angle, we can use the law of sine for anything else. So for that, you could have found angle PRT, but what I did, I just did cosines again since it's a easy formula, as I think. So then we set it up for P to find angle P. So we had 10 by itself, and then having 11 and 20 plugging in for the rest. And so we got angle P to be approximately 16.9 degrees. And then with all of our answers or degrees, angles that we got, we stored them into our calculator so we could add them up and subtract that number from 180 to get T to be 18 and 6/10 degrees.
So we use the definition of triangles to find measure A. So 50 plus 60 equals 110, and then 180 minus 110 equals 70. And then to find the length of m, you do the sine of 70 divided by 13 equals sine of 50 divided by m, and then you cross multiply, and then you can divide 13 times sine of 50 divided by sine of 70 to get m equals approximately 10.60. And then to find y, you do the sine of 70 over 13 equals sine of 60 divided by y. Cross multiply 13 times 60, or 13 times the sine of 60 divided by the sine of 70 is equal to 11.98 approximately, which is y. And that's it.
Alrighty. So Liz has climbed a tree. She's looking down at Justin. He is 20 feet from the tree. So draw the line 20 feet away from the tree, and in inches that's 240. So, and everything else is in inches. So we're gonna put it that way. And his eyes are 50 inches above the ground. So let me draw that right there. And then the angle of elevation, looking up at Liz from that child, the boy, is 48 degrees. So that would be here on the triangle. And then Cal would like to talk about the next part.
Alright, so to find the height of the tree, you want to take the tangent of the, I guess I don't have to point at it, the tangent of the angle, which is x over 240, which is the opposite of the adjacent. And then you're going to multiply both sides by 240. Write it out.
Sorry, some guy just broke into the room and tried to steal our stuff. Equals the tangent of 48 degrees.
And then you're going to multiply each side by 240.
So x is equal to 240 times the tangent of 48 degrees. And if you were to solve that, it would come out at
266.55 approximately. And if you take the actual number in the calculator and add 50 to account for the height of Dustin, his eyeballs, you would get approximately 316 feet, 0.55.
It's actually in inches. So 260,
yeah, something like that,
is equal to this right here. And then that's 316.55 inches equal to the height of the entire tree.
Good job. You solved the